Hey, Ranni here. Shall we make a game? So yes, we are once again back into the world of navigation meshes, and last time it looked like we got them kind of like, cross-compiled. We were about to visualize it and see what we got just to make sure it was working. So I just tried doing a build and I got some errors. Let's work our way through them and figure out what's going on. So it looks like, because I have this parameter here for passing in the image for visualization, we need an image. We're going to need that C file as well. Oh, the C file is literally a copy of the H file. Okay. Yeah, okay, right, okay. I didn't actually, okay, I remember now, yeah, I didn't actually get around to writing any of this code. That's fine, we'll do it now. We're also going to want matrices, as we're going to be doing some matrix multiplication as part of this. So we don't need the struct. The struct is the thing we're going to be interacting with. And this is what we're implementing, this here. Yeah, we'll put a big fat to do in there for now. That's my kind of solution. So let's go to the movie theater script. And let's import a nav mesh component. Oh, hang on. I keep calling it nav mesh. It's navigation mesh component, otherwise the spell checker shouts at me. And let's drop on. Oh, I need to implement kind of like an importer for navigation meshes. Yeah, let's do that. Let's put this in a navigation mesh file. And this kind of goes below the main type as it's a constructor for them. So we can now take all the instances of mesh and replace them with navigation mesh or naivigation mesh. That's a better pun than the one I put on the stream, isn't it? So I need to start thinking about it. We're kind of like beginning to, we're in the second half of this kind of project. We're drawing towards the end of it. It just is no way a finishable game is going to be even remotely feasible. What the heck do I do next for this? Because this has definitely been good in that it's got me to, really stick with a project and really kind of pull it a lot further than I normally would. But I'll be honest, it's kind of hella exhausting doing this quote unquote recreationally every single day after working on similar stuff. And if I don't keep that kind of cadence up with it, it's never going to progress particularly far. I mean, look how little distance we've actually managed to get in the last month and a few days. Oh my god, I can't type and talk. There we go. Yeah. So at that point, I have to start thinking about, like, if I want to do more of this, how am I going to do it? Because I can't realistically just do this 7 days a week on top of other duties. That's just not really quite possible. Could I say do this for my weekend streams, which tend to be different anyway, just because not everyone's available who would be available during the week. Because that would also actually work out quite nicely, because I tend to have more like 2 hours per weekend day, which rather than the 1 hour I normally have per weekday, which would mean that I would be getting a nearly 50-50 split of time on playing games and time spent making games. And I could always chip away a bit off stream, because it does take less energy definitely to do this kind of thing while yes, that's just reading that while typing. It does take less energy to do this off stream. It does it on stream, so maybe that's what I do. Priority after kind of like finishing this 2 months of self-imposed torture, though, is definitely going to be to try and package up the engine to something that can be, you know, sort of maintained separately. Okay, so we also want to pull in our navigation mesh, not the component, the mesh itself. We then want to import navigation mesh there, and then I'm going to create a navigation mesh component, attach it to the world, and it doesn't have a parent component ID, and then it's going to be that, I think. Let's see what that does. It's probably going to shout at us. We've changed the header file, so I'm going to do a parallel build. See where we end up. Oh, yep, we definitely had a few disagreements there. Let's do another build and see what the errors actually were. What's this talking about? Oh yeah, so I've got the _t suffix on it, which I shouldn't really have. Okay, we have conflicting types. Why do we have conflicting types? What's conflicting about this? Ah, that should be a pointer. And we're also going to want to bring in our line header. We're going to be using lines to visualize this. Okay, that's good, that's good, that's good. Next up, I need to add a function here to visualize them. So I'm going to steal this function here. Layers, debugging. Oh, hang on, I put this in the wrong file. This should be in the navigation mesh component, not navigation mesh component file, not this navigation mesh file. Too many words. Okay, and then I'm just going to stick this into here. And then I'm going to call into that from the API file, which is, sorry, the advance function. We want this to be very, very, very late in the process, so I'm thinking there, that'll probably do. Right, and now we loop through them and render them as required. So if it has a matrix, then we render it there and then. Nice and simple. Ah, but it's not the component, it's the actual mesh we're layering. So grab the appropriate mesh, grab the appropriate matrix. In fact, I'm going to store this in a variable just because we're going to be using it multiple times. And it's going to be const, and it's a pointer. That's good. And the final thing is the image, which should be the video buffer. So I'm just going to grab that out of here. And we don't need to return anything. Okay, that should be good. Okay, next up, I just need to make this do something so I can tell whether it's working or not. So I'm just going to make it just draw a straight line from one corner to the other. And I'm going to draw it straight to the image. I'm just going to void these off just so that it allows the game to compile. But at that point, if everything's working, we should see a nice line running from one corner of the screen to the other. Did I not add any arguments to this for color? I didn't add any arguments to this for color. Okay. All right. Okay. Bit weird, but okay. And we need to turn that into a pointer. Oh, wait. No, we don't. No, we don't need to extract the imported navigation mesh. Okay. Okay. Looking good, looking good. Still thinking about it, but looking good. I should have done a parallel build of this, shouldn't I? Come on, compiler, you can do it. I believe in you, I think. Okay, I don't see a white line in the corner, which implies that isn't working. All right. Oh, we don't need selectable component IDs in here. That's something we can remove straight away. Just don't need to destroy anything when we destroy one of these. Okay, that should be working, shouldn't it? Let's intentionally throw an error here and make sure that we're getting to this part. Let's open the inspector so we can see it. Okay, we're not hitting this code at all, so something's definitely going, oh, what's this? It's not happy about something, is it? Oh, I know why. We never needed that import statement. You know what? I'm going to leave this in, just because it means that we can later on, if we ever need to have a function, we can make that work. It just means it's following the pattern. And then we can just reuse this exact thing up here. And it's a bit bad to be copy pasting code, but it means we can edit them as required. Oh, it didn't like something. What didn't it like? Because it's a const here and it's not a const over there. Okay, whatever. Const correctness is something I definitely need to review in this code base. It's something where I learned some things about the language features after I started working with it. Okay, that seems to be building. Happy days. Let's just make it a parallel build so it's fast. Come on. Okay, are we done? Are we done? We're done. Okay, there's our line. That's good. So next up we need to come into here and we need to make this do something actually useful. So we're going to iterate over the triangles and then we're just basically going to draw there, kind of like wireframe. It'd be kind of useful if we could color these lines in, so that we could clearly show. Okay. Oh. That wasn't meant to be a slash, was it? Okay, we're going to work for these triangles in order, transform their vertices, and then draw lines between them. It should be dead simple. Yeah, I wonder why that line drawing function, why I never gave it the ability to pass in a colour. That's such a strange thing to omit. I wonder why I did that. Okay, so we can get the 3 coordinates out. I forget the best way of doing this actually. What I could do instead is I could do this with pointer arithmetic because I'm feeling dangerous today. So if the triangle start is going to be the first triangle in there, and then triangle's end is going to be start count. Okay, and then we can do this very neat thing where we can iterate from the start to the end. And then this looks wrong every time because it looks like it should be only advancing by a byte, but it actually advances by an entire struct. We just increment like that. And now we have our triangle in here. How nice is that? So we have our 3 vertex locations. So yeah, we can get our first location. And let's then transform this into display space. So we're going in the matrix. I think we have matrix image. Yeah, that's the one. Yeah, and we can give that a point in 3D space. So we can actually give it the first vertex location like this, and we can give it model view projection matrix, and let's fetch the number of rows out of the image and the number of columns. I'm going to be using that quite a bit. And then we're going to be writing out the row and the column. I forget, is it a float or is it an int? Oh, it's all floats. Tasty. I'm not going to be using the depth that we have to provide one anyway. And we need the math header, so I'm going to pull that in. So if it's not a number, every time I say that, I have to kind of stop and sort of chew on the words a bit. Then we transform the next one. Oh, actually, I should probably make these kind of like a row, and then that way I can store all 3 coordinates together. So next up, we're going to get the B, and it does mean this line drawing function that we're currently going to be using doesn't have any concept of depth, but I think that's probably fine. This never was going to be a particularly deep game, let's be perfectly honest. And they're not const because we're going to be overwriting them. Let's not last line affect this if we can. Well, if we can't. If at all possible, there we go. Happy with that wording. So now we have 3 points in display space, and now we can actually render them. So draw a line. Provide our coordinates and provide our destination image. I'm just going to draw 3 of them. So AB, BC, and CA. And this should give us a mesh on the floor that we can kind of see. Oh, it's not happy about something there. And this is the thing of whether, where do I write const? Is it left or right of the type? I don't remember. For now, I'm just going to drop const out of this because it's not a big deal. And this, it's not a big deal really. I'm not sure how I feel about putting const in things. On the one hand, it feels nice to make things immutable. On the other hand, at least in C, it seems like really hard to kind of like do that without trapping yourself. Okay, that's, oh, it's going to change the header file. Fair enough. Keep building. What's this talking about now? Doesn't seem happy about something. Oh, it's because these are... Okay, right. Yeah, we're kind of like discarding the fact these are const. So I'll make these non-const for the moment. It's fine. I'll do that review I'm totally going to do. We'll fix it then. Build. Oh, this terminal's frozen up. Great job, Visual Studio Code. I will restart the terminal. Oh no, some not the numbers have creeped back in. How have they done that? If I build again, do they just go away? No. Okay, let's have a look at what it generated. What did it generate? Is there anything special about this line that's become nan? So that's a triangle, that's a triangle, that's a triangle. Where's the matching brace? No, that isn't a triangle. What am I talking about? That's a triangle. That's a triangle. That's a triangle. And that's a triangle. Right, so this is in that last group at the end. So that looks like it's in the edge normals. So that's going to be AB, BC, CA. Okay, what do we have with regards to coordinates for this triangle? Here they are. Let's see if we can find this in Blender. As the root cause may become more obvious as soon as we can visualize this inside Blender. Come on, Blender. Here, Blender. Okay, navigation mesh is visible and we've got it selected. Good, let's resize this bigger. So our first coordinate is 7.16. Well, it's either that or that. So let's go with that one. 0.24 minus 1. So that's one of the vertices right there. Next one is 3, so it's probably this one. Okay, so it looks like it's that. That is somehow producing an invalid edge. Hang on. Let's have a look at the figures here. So we've got it's definitely that one, and that one. Now we can see that one of these edges apparently has a normal along. It'll be this edge. It's kind of pointing that way. So that one's correct. Get out of the way. This one is primarily pointing that way, so it's probably that one. So it's this one that's going a bit wrong. Well, let's have a look at the code to actually convert. Let's have a look at the code specifically for edge BC. What do we have here? That looks pretty normal so far. Yeah, this looks... Everything about this makes sense to me. So I've got some kind of bug in here. I think I've just noticed as I'm doing this. Why am I doing this? Why am I copying the same thing over? Oh, hey, hang on, that's not the same thing. All right, yes, that's right. Yeah, I remember working sort of like digital paper last night. That makes sense. BBB, CCC, that's fine. BC, 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 BC. That looks fine to me. There'll be a last line effect in here somewhere, I just know it. Is it possible we've got an invalid neighbor number? That's definitely possible. Let's see here. So this is triangle 1, 2, 3, 4. So what's in here? 1. Let's just put new lines in so we can keep tracking these. 2, 3, 4. So it's apparently going to be this triangle. So this only seems to think there's a neighbor on one edge. It seems to be missing the neighbor on this edge. Now we did work out earlier that the normals seem to be this one. That one's definitely especially missing, but it looks like it's missing the neighbor on the first edge. So we might have a bug with our neighbor detection code. Let's start writing up a to-do list. And let's also have a look at some of our neighboring the other triangles in here and see if they make sense, because there might be some kind of pattern that we can spot by comparing it to another triangle. So we have a triangle here that is, I think that's the back. Yeah, that's that one. Yep, that's that vertex there. This one should therefore be that one. Yep, that's correct. And then this one should be this one. Yep, that looks right. So what do we have here? We have surface normal pointing straight up. That's fine. We have an edge pointing that way, which is fine. We have an edge pointing... Oh, it's actually not. I thought that was straight, but it's not. So yeah, we have an edge pointing mostly left, but slightly towards the camera. And then we have an edge facing slightly right, but mostly towards the camera. So again, that's going to be that. That's going to be that one. So that one's worked. Hang on, excuse me. That one has worked, but that one hasn't. So we need to figure out why that is. What's special about this triangle that means that this one works and this one doesn't. So the neighboring numbers, right? They're different. So yeah, this is the only triangle where edge BC is the one that's got a neighbor. Oh, fantastic! Hope you're having a great evening. I'm mostly just staring into my own mess and trying to figure out what the hell I've done wrong. So, what are we putting in here? Is what we're putting in here going to be correct? Okay, so that seems to follow the pattern. So looks like that bit probably works. What kind of reflex game? Are we talking about, because like, said reflex game, I'm thinking sort of like rhythm game or something like that, but I've not played any really difficult rhythm games actually, but they can get quite aggravating. Oh, I should look that one up. I'm probably quite out the loop on it. Okay, so the next thing I'm gonna do is I'm just gonna print out the actually I've already got the neighbor numbers here. Hang on. 12. These are all multiples of 3. Ah, hang on. I know what's going on here. These aren't triangle numbers, they are edge numbers. Oh, is it one of these things almost, not actually a mobile game, but kind of like a mobile game in that you've got kind of like very small kind of like but difficult challenges? You know, once you kind of got the hang of them, you can say get through them in say under a minute. But you know, that minute long stage will take you an hour of trying. Okay, so that kind of thing, yeah. I'm almost envisioning the lock picking mini game in Oblivion. I always really liked that one. Really simple, but it kind of got the idea across. So I can get rid of all these, I think. Not quite sure why I did this. Why I tracked the individual edges. Let's see what that does when we build it. That seems to have built. Let's see what we've got. Hey, that's a nav mesh. That's a nav mesh, all right. Okay, next up, we need to. I think I'm going to add a feature to this line drawing thing so I can specify start and end color so I can tell what I'm looking at. That shouldn't take super long to implement. Yeah, have fun. I hope it's not too aggravating, or maybe if it's fun because it's aggravating, I hope it's suitably aggravating. Okay, so we've got this bit here where it's currently setting the opacity here. So not the opacity, the color here. We actually want to do our interpolation. So, Okay, I'm just reading this and trying to remember how on earth I did, what this actually was. So that's if it's only occupying a single pixel, which is probably a micro optimization, probably need to do that. And then, that's right, if there's more columns and rows, it basically kind of iterates over the columns and then does a bunch of horrible division, which is probably hella slow. I'm probably going to end up just doing linear interpolation here. I don't really see a way around it. Do I have a color interpolation thing? Do I not have a color interpolation helper? Well, time to fix that, I guess. Well, that said, probably want to calculate the deltas, don't I? Yes. Let's come to here, let's calculate our deltas in here. But I need to do it based on my reverse rating over columns or rows, so And I'm doing this in floating point just because the accuracy doesn't the accuracy and precision don't super matter, but most of the operators are faster in floating point than they are in integer space, such as division and things. Also, you get fewer headaches with like rollover and stuff. Okay, so now we can calculate the amount per column. Yes. I don't remember why I actually wrote this line drawing function. I haven't really used it for anything. I could have had it left over from previous code and I just brought it across because why not? Okay, and then roughly using the com delta, we're using the row delta. And then, yeah, we'll make a new color. Oh, that's right, we need to actually accumulate the colors, don't we? Yeah. Okay. Yeah, so as we kind of iterate, we're going to keep stacking the amount per pixel onto these. That should do. Oh yeah, we also need to prefix all these, don't we? Oops, my bad. Okay, and then we've got some checks in here to make sure that we're actually drawing pixels on the screen, but even if we're not, we still want to increment these accumulators. Something I've been thinking about is how I'm exactly going to interact objects with this, this nav mesh, because I can put a component on that updates the transform sort of every frame. That wouldn't be super hard to do. But then you've got things like AI and like physics, because you can say like have objects that bounce and things like that. There's actually got a lot of complexity here. Like, do I have like a separate controller component that tells the kind of, one that actually does the physics and then one that tells it sort of how to react and respond, and how's that interact with animation, for example? A lot of things to think about. And it may not surprise you to hear this. I haven't really thought about all of them, any of them until now. Okay, what's this talking about? What isn't this happy about? It doesn't like it because it's not an integer. Fair. I guess it's cast into floats here, that'll do. So to ints. It's throwing an error because I have not put these back in. So what we can now do is we can now stick some colors in here. And this should give us a good indication of exactly how our geometry is arranged. Another tweak I'm going to make in just a second to that line drawing thing is, no, actually I'm not going to make that tweak. I was considering, should it say skip the last pixel so that, you don't get double drawing of transparent, but we'll figure that out some other time. So others have some helpers here we can use. And these are cased incorrectly, aren't they? Yes, they are. I felt the the colors are kind of maxed out 0, 2, 5, 5, whatever. I think we should call them like programmers red and programmers blue, because no one in their right mind who wasn't a programmer would ever use such completely garish colors. Okay, I think that's working. Looks like it might be wrapping actually. We've got colors, but I just don't think they're right. Well, these should be called per row for a start. Wonder where it's going wrong. In theory, I could be doing a reciprocal here as well. Okay, that doesn't change the look at all. So let's do a quick test. Let's as part of this, let's draw a single line from the top left corner, just so we can see, whether it's just the fact we're layering up a bunch of stuff or whether there's something really going wrong here. So this should give us a nice line in the top left corner of the screen that fades nicely from red in the corner to green in the center. Something's going wrong here. That looks like it's hitting the, that looks like it's wrapping backward. Yeah, what is happening there? Because it's kind of fading, but then kind of like hard cutting in the middle. It looks like it's about to reach kind of like yellowish. Let's try going from black to green, because this should give us a nice kind of like, gradient from... See, that looks vaguely right. So let's try the other way around. Let's go from green to black. This might be a last line effect style affair where I've used the wrong... No, that's all look good. Oh yeah, it's when it's descending. So what could be causing that? I think I know what it is. And I think I'll fix it by doing this. It's because we're getting unsigned integers out of those calculations, and unsigned integers do not support going back around to 0. And these shouldn't really, these should be... Yeah, let's make these signed integers explicitly. That'd be good. I have been kind of tempted to eliminate all unsigned integers throughout the whole code. There we go, that's fixed it. And that immediately looks better. That's starting to look more like how we'd expect, more like what we'd expect. Okay, so for the sake of testing, I'm just gonna get rid of that line in the corner first. For the sake of testing, I'm going to mangle this nav mesh a bit. Let's get rid of all faces except this one. Let's rotate it towards the camera just so we can see what we're doing. And let's just re-export this. So this should give us a single triangle there. So that looks good. Except it doesn't quite look good. Looks like we've got some kind of issue of our vertices being flipped. Red to green, A to B, B to green, C to blue. Why are red and red in different places? Something's wrong there, isn't it? Have I got it backwards in the line helper thing? Because we're starting from A and we're going towards B. So that should be correct. Oh, I think I know what it is. Yeah, I know what it is. I've got this bit up here that so we never have to go backwards. It flips the line if certain criteria are met. So I just need to make it not do that. Yeah, pretty simple to do. We'll just flip these around. I forgot I did this. This is probably actually like really bad for performance, to be honest. But I'm trying to focus on things more important than my terrible line drawing algorithm right now. Okay, and then this down here, yeah, this all needs to, I can't reuse that code between the two branches because it needs to be left or right depending upon exactly what situation we're in. So what are we doing here? We're going from left to right rather than A to B. And then we're going to do something very similar down here with it. We can actually just, this one where it's going to be, instead of A and B, it's going to be top and bottom. Okay, yep, that's fixed our issue with the colours not being continuous. That's good because we're about to use it to visualize something. So next step is, yeah, next step is we want to visualize the kind of bits that stick out of the sides. So I'm actually going to split this up into separate checks. I'm basically going to make it calculate the corners and then only draw the lines if both of the bits that it needs are there. Oh my god, I've got so little done today. Oh my god. It's been 50 minutes and I've basically just achieved nothing I was looking to achieve today. Ah! Okay. How's this look? Identical. That's good, that's good. Next up, we're going to calculate the, I'm going to calculate a point for the surface normal. So yeah, so we need to average the 3 points to find the middle of the triangle, and then we add the surface normal to that to get a point along that axis. Hey, this is looking like code that should really be handled by a vector framework, isn't it? And we do something very similar here where we calculate the beginning and end. Nice and simple. And then we need to use that in there, otherwise we're calculating the position of something we've already calculated. And then draw the line if we've got everything we need to do that. Okay, and I think we just go white along the whole line. Let's go the other way around. Let's make it sort of kind of like, could I actually make it kind of like fade? That'd be good. That'd be really attractive, wouldn't it? Okay, seems to be building, that's good news. Oh, I changed the header file. It's going to be building a while. Come on, you can do it. There we go. I've done something wrong there. Okay, I can't see that line. That's not good, is it? Let's have another triangle next to it, see if we can see the line there. Oh, it's up there for some reason. Huh. Oh, hang on, I know why this is. It's because I'm trying to calculate the mean average and I'm not dividing. What am I doing? There we go. And let me just check that the back faces are enabled. I suspect they may be backwards. Oh no, they're actually the right arrangements. I modeled them backwards. That's refreshing, isn't it? There we go. So those appear to be going the right way. I'm going to make this transparent, see if they work nicely like that. If they do, I'm going to use that same trick for the edge normals to try and make them, look nice and clear. Don't think it's quite worked, but let's make it so it layers nicely onto there. Okay, let's replicate that up here. And that should give us transparent lines. Should. Whether it'll work or not, different matter entirely, but it should do. There we go, it's nice transparent lines. Now we can use it to kind of render the bits kind of poking out of here. So yeah, let's go back into here, and it's very important to make sure these are actually correct before I try and build any logic working on them, because otherwise I won't know whether my collision is broken or whether my mesh import is broken. All right. Reduce these to 2. I'm just going to use 2 of these. What do I call this? Edge normals. That makes way too much sense. I would never have called it something so logical. Okay, so that should... Oh, I actually need to write the code to actually put it on the screen. And for this, because it's going from red to yellow, I'm going to make it, so red to green, I'm going to make it yellow. Don't currently have a constant for that. Let's keep filling these out. They're good to have. I do mean a full recompilation of the the code because it's editing a header file, but we'll deal with it. That's going to be... Is it cyan or is it cyan or whatever it is? Who knows? It's that color you only ever see in computer programs because no one in the right mind would use it for anything real. And magenta, another color that, again, no one in the right mind uses outside of a computer program. Okay, this should... Let's finish compiling. It should... Okay, it's kind of hard to tell from this angle whether that's going the right way, but it looks... That one looks kind of right. That one kind of doesn't. That one kind of looks like it's a weird side angle. So let's add the others and see if they look any better. That's AB. So next up we want BC. And we're going for the midpoint of B and C, and we're going to use the second edge normal. How's that look? Okay, that one looks more correct. I don't quite get why that one's pointing that way yet, but we'll figure it out. Actually, let me just have a look at this. Is that... You know what? That might actually be correct. So they're looking kind of correct so far. Like this one is kind of not pointing quite the direction. I'm gonna have to check what happens if I like put something a bit more carefully posed for the camera, so we can see whether it's correct or not. Okay, almost there. And this one is going to be magenta. And we need to calculate where we're going to put that on the screen as well. And again, swap these around a bit. So we're using C and A. And then we're using edge CA. Okay. It means it's not defined. Don't tell me I typoed it. No, it's right there. And then just your code's like, oh yeah, it is. Okay. Those don't look like they're averaging out. They should be kind of like opposing and they're not. Let's give ourselves a nice test case. Let's grab these and make them so they're basically parallel with the camera. So I should be able to see very clearly from that whether they're lined up properly. Yeah, those don't look lined up to me. Those should be kind of parallel. So if I go through to my converter here, we have... Should be the bit down here where it kind of looks at the... Yeah, here we go. It's a bit where it's effectively like... after it's matched up the neighbors up here, it's looking at the triangle and trying to figure out if the sort of edge normals need kind of distorting to take that into account. And the way I'm approaching this is I'm basically adding the normal of the neighboring triangle 2 hours before I do the normalization, which should mean that they kind of like average out. As they are both normalized at that point, so you don't have the risk of one of them having more influence than the other. Okay. I want to get this working for a kind of stop tonight, so at least got some pretty visuals to put on Twitter. Okay. Okay, what happens if I... What happens if I intentionally dummy out the thing that is meant to be averaging these two together? Because that'll give us an idea whether it's working or if it's, whether this code's being hit at all or whether it's not producing the correct result. Okay, so that has produced a different result that makes even less sense, which is Good. I guess. Let's run another make. Let's have a look at the raw data after that and see if we can figure out what's going on. Maybe as well, we produce kind of like an idealized test case for this. Actually, they're already pretty idealized. I mean, like, most of it's going to be pointing straight forwards or backwards. There should only be like one shared edge that kind of like does something interesting. Let's just get us back into here. Yeah, so it's doing this weird kind of bent light thing, which isn't quite right. Bring up the this. So we've got two triangles, 1, 2, and the coordinates look right, the surface normals look right, so it's actually just... Hey, how's it going? How's it going? I'm almost done for the night, but I'm currently trying to work out a few bugs with my nav mesh importer, which isn't quite working yet. Oh, actually, here's something weird. I've just spotted something. Only one of the triangles thinks it has a neighbor, the other one doesn't, so there is a bug there. That would explain why one of these is kind of bent towards the normal and the other one's gone straight. So that's the issue. So next question is, which edge is the one that should be kind of bent? So it splits into the two triangles, and that one's shared, that one's shared, that one's not shared. So AB isn't shared, BC is, so that's correct. And then in the second triangle, it should be CA. So this third one here shouldn't be none, it should be something. So we have some kind of bug there. So let's go back up to here and so what we're looking for here is that CA that's kind of interesting. Hang on. CA should be matching BC. So do we have a check for that specifically? CA, CA, BC. Okay. It's one of these triangles backwards or something. So BC, and then that kind of looks like one of the two triangles has got a flipped edge. And they definitely don't. So we've definitely got some kind of edge matching bug here. Hang on a second. Let me draw this up. Let me get a sprite up. Hopefully it lets us draw today, because sometimes it doesn't let us draw and I don't quite know why. Yep, it lets us draw today. Okay, good, good, good. So what we have here is, let's just figure out where these are in Blender, and then we can kind of draw them up and figure out where it's going a bit wrong. So it's none of these coordinates match up actually. That's kind of weird. Oh wait, that one does. That one does. So that's 6, 1. So that one is, let's just draw this up a bit like this. So this is this is triangle 1. And then we have minus 1.4. So that one's B. And then this one must be C. And then we've got a second triangle, which is over here. And how's this one laid out? So we know that. So that one's A. And this one must be unique, so that one must be B. And this one here is C. Yeah, that one's also C. So let's see here. So, if I pardon the pun. So the problem is that triangle 2 isn't seeing that it has triangle 1 as a neighbour. So CA is not seeing BC. CA isn't seeing BC. ABC, ABC. But BC is seeing CA. So what I'm kind of asking myself here is, because I kind of always just sort of assumed that the edge order would be kind of flipped when two triangles are kind of neighboring, right? But is that always true? It's true in at least one case, but is it always true? Well, I am naturally looking at some data where it's not true, so... No, wait, it is true. It is true because like C, C, A, B. Yeah, that's going that way, and that one's going that way. C, A, C, B. C, A, C, B. This should... What? This should be matching up. This should be finding a match. Let's put a huh in here and see if it hits that. It hasn't hit that. That's kind of interesting. Do I have a bug where I'm pulling the wrong indices out? Doesn't look like it. Huh? Now I'm just really confused. We don't have any early exits out of this, do we? Ah, I've just spotted what it is. It's this optimization here. It means that a later triangle can never intersect with an earlier triangle. Now, I did put that in for a reason, and I don't remember what it was. Whatever. Let's just run it and see what happens. Well, it didn't crash, so must have been no good reason. And indeed, those two lines are now opposite directions, meaning that we have kind of like a line going this way that they can both kind of, they both agree on at what point you switch between the two nav mesh triangles. So let's just do a nice little sort of test nav mesh, something that actually looks good that we can stick on Twitter, and then call it a night. That was equally as painful as I expected. Let's do a nice little kind of like banked corner over here, something like that. Let's do a bit of Tony Hawk. Wow, that's a lot of lines. Okay, I'm just going to move that around a bit. Let's just move it a bit close to the camera, maybe scale it up slightly. And so have a look at how it looks through our camera. And let's maybe kind of rotate it slightly. Just going to get a really good view on it. There we go. This is also, oops, I made the floor a camera, oops. It's also just going to give us a good idea of, just a quick little sanity check and just make sure that nothing looks super obviously wrong with this. No, that actually looks good. It's made kind of like, nice kind of like opposing lines there and there. I might just go into here, and where I've actually got the bit adds the normals, I might scale it down slightly just so it's a bit easier to read what's going on. It's getting a bit difficult to distinguish lines to do with kind of like edges of triangles from kind of like direction indicators. Maybe slightly less than that. Well, slightly more, that is. If you get what I mean. Less, which is more. Yep, that looks really healthy. That looks good. Got these nice boundaries in here. So yeah, the idea is that you're going to be able to navigate the world. Obviously, AI characters can like cross nav mesh edges to get from A to B, but also you'll be able to have actual players navigating by having them crossing these lines, and then when they reach an edge, it basically projects their kind of position along the edge, so they get sliding collision. Nice. Well, thank you very much for watching, and I hope you have a great evening. I'll be picking this back up tomorrow, but probably only be doing an hour, even though I've been occasionally doing 2 hours at weekends.